I start by looking at the diagram, and what I can see here is I have a coil with an electrical supply, so immediately I start thinking electromagnet. Now the supply is actually an alternating current, which would actually immediately indicate to me that I have a changing flux. I have an iron rod as a core to my coil and an aluminium ring which appears to be floating. Reading through the question, I see I've got an experimental arrangement can be used to demonstrate magnetic levitation. The iron rod is fixed vertically inside a large coil of wire, so there's my electromagnet. When the alternating current, so I'll spot it a second time, supplied to the coil is switched on, the aluminium ring moves up the rod until it reaches a stable position, floating above the coil. Now this moves up looks interesting to me. Looking at the actual question, by reference to the laws of electromagnetic induction explain, as soon as I see electromagnetic induction laws, I think Faraday's law and Lenz's law. I then read through the next three. Why will the current be induced in the ring, why it experiences a force, and why the ring reaches a stable position. So looking at the question, why is the current induced in the ring? Well, for this one I'm going to use Faraday's law, and Faraday's law will state that whenever I actually have a change in the magnetic flux passing through a conductor, and here I will have flux going through a conductor which will actually be changing, and the reason it will be changing is because we have an alternating current, so it will be changing direction here, then I will actually create a current. The magnitude of the EMF is proportional to the rate of change of the magnetic flux linkage. So the higher the frequency of my AC supply, the greater the rate of change of flux, and hence the greater the current would actually be. The EMF induced causes current to flow in any complete circuit, and as the actual aluminium ring forms a complete circuit, hence I've answered this question, the current will be induced in the ring. The next part of the question, why the ring experiences a force that moves it upwards, is actually Lenz's law. And Lenz's law states that the induced current flows in such a direction as to oppose the increase in magnetic flux when the current is switched on in the coil. So the current induced in the aluminium ring acts to oppose the change that created it. And this actually will create a magnetic field in the opposite direction to that produced by the coil. When I actually look at the interaction between those magnetic fields, they will act in such a way that they repel each other, and hence the ring actually floats. The final part of the question is why the ring reaches a stable position. Well, the ring would have started off on the coil, sitting on top of the coil, and when the actual current was switched on, that would induce a large current within the coil, which would actually act in the opposite direction to the weight. So we would actually have a force exerted upwards. This is actually greater than the weight, and hence we'd have a movement going upwards of the iron rod. They would reach a point at which the aluminium ring stops and reaches a stable position. Now the reason that happens is that as we go further from the coil, the magnetic field weakens and hence the flux linkage decreases. This would actually have the effect of decreasing the current in the aluminium ring, and by decreasing the current in the aluminium ring we actually also decrease the magnetic field that it's producing, and hence we reach a point where it hits a balance point. And here is a mark scheme, so you can go through the paper and mark how many points you actually managed to pick up.